Hi, today we will work on the chain rule. Okay? We use chain rule to differentiate composite functions like f of g of x, right? Or f composite with g of x. Okay. So the rule is tell us that let f and g be functions, then the composite function f of g denoted by f of g is defined f of g of x or f composite with g of x equal to f of g of x. So in this case right here, f is what we call the outer functions, and g, the function g, is the inner function then. Okay, so then now let us look at the following example. If I want to find the f of g of x, if f equal to x squared plus 2 and g equal to x minus 4, okay, so how do we actually work it out this problem? Okay. Then, first of all, we know that f composite with g of x, we could write it as f of g of x, okay? And in this case, we could replace the g of x with x minus 4. So we could write this as f of x minus 4, right? Like this. Okay. And then now let us go back to the f functions now. So I have f of x equal to x squared plus 2. So in this case, x is the input. So if we work with the input, we could consider that the function is kind of like we have the input and then we square the input and then we add 2 to it. Okay. And now, what is the input? Okay. The input is x minus 4. Then we just replace x with x minus 4, right? Just like this. So the answer to this one will be x minus 4 to the square plus 2 then. So this will be the composite functions. Okay. And now, what I would like to do is, I would like to get it from the composite function back to the f function and the g function. We call this decomposition, okay? So right now, just like this one, we would like to find two functions, f and g, so that the given function is the composite functions or the composition of f and g then. Okay. Or we could identify the inner function u equal to g of x and the outer function y equal to f of u. Okay. It's another way to work it out the problem this way too. Okay. Then let us look at back to the example that we have. Okay. Now, do you see that if I box x minus 4 and I assign x minus 4 to the g functions, then when I create the f functions, we could replace x minus 4 with x. Then we will have x squared plus 2, which is the f function then. Okay. Okay. So if I use this idea right here to work with the following example here, what I would like to do is, again, I would like to box the 2x to the power 3 minus 3x squared plus 2, okay? And I make this to be the inner function, which is my g of x. So I would like to let g of x equal to 2x to the power 3 minus 3x squared plus 2, okay? And now, if I create my f functions, then remember the one at the box, I work with x, I replace it with x. Then the f function will be x to the power 5. Okay. And how about the b now? Okay. So in this case, you will see that to this function y equal to e to the x squared minus 2x plus 1. This function is work with the exponential functions. Okay. So to the exponential function, what we could do, we could assign x squared minus 2x plus 1 to be the inner function, which is the power of e, right? So again, in this case, if I let u or g of x equal to x squared minus 2x plus 1, okay? Or we could let u equal to g of x then. Then now, the one that I box it, I replace it with x when I create f functions. So my f of x will be e to the x then. Okay. Okay. So similarly, if I have y equal to sine of tangent of x, then you will see that the inner function, okay, is tangent of x. So then I would like to let g of x equal to tangent of x. Then now, what is my f function then? My f function will be sine of x. Okay. So this idea right here is what we call the decompositions then. Okay. So now, in order to work it out, the chain rule or to work with the chain rule, we have to have the sense or the technique or ability to find out the inner functions, which is the g functions. And then after we find the g function, then we have to think of what is my outer functions then, which is the f function then. Okay, so this is kind of the idea. Okay. Then now, let us look at the chain rule. It said that if g is differentiable at x and f is differentiable at g of x, then the composite functions capital F equal to f of g, denoted by f of x equal to f of g of x, is differentiable at x, and f prime is given by the product. So f prime of x, which is the derivative of the composite functions, is the product of f prime of g of x multiplied to g of x, g prime of x then. Okay. So in Leibniz notations, if y equal to f of u and u equal to g of x are both differentiable function, then dy dx equal to dy du times du dx. Okay. Let's see how we get the Leibniz notations. Okay. Okay. So a couple of things that you need to know is y equal to f of g of x. We start with this. Then we will have dy dx is equal to f prime of g of x times g prime of x. This is what we know. Okay. And now, to this one, I will have y equal to f of u, where u equal to g of x. Okay. So basically, it's added here. Okay. And then now, let's see how we take the derivative now. So y is dependent on u, so y prime is dy du, okay? And then now u is dependent on x, so u dx is g prime of x. Okay. Okay. Then now you will see that f prime of g of x, basically it will be f prime of u times g prime of x. Okay. Then now, look back to this one. F y prime is dy du, which is f prime of u. Okay, so then in this case, f prime of u, it will be dy du times g prime of x is du dx. Okay, so this is actually how we get the Leibniz notation for chain rule. But in this section right here, mainly we will use this one to help us to finish the problem then. Okay, so let's see how do we actually use one, okay? This one right here to help us to find the derivative of y then, okay? Okay, so right now, let's try to identify what is the inner functions and the outer function first, okay? So in this case, I would like to let g of x equal to 2x to the power 3 minus 3x squared plus 2. Okay. And of course, in this case, I will have f of x is equal to x to the power 5. Okay. And now, let's see. I take the derivative of g, which is 6x squared minus 6x. And the derivative of f is equal to 5x to the 4th. Then. And now, I have y prime is equal to f prime of g of x times g prime of x. Then you will see that f prime of x is 5x to the 4th, and f prime of g of x is 5 times 2x to the power 3 minus 3x squared plus 2, right, to the 4th. Okay, so then now we will see that f prime of g of x is 5 times 2x to the 3 minus 3x squared plus 2 raised to the power of 4. And we multiply to g prime of x is 6x squared minus 6x. Okay. Now you will see that if I always work with the outer functions f and the inner function g, then it's kind of messy, right? So basically, the idea about the chain rule is if we take the derivative of f of g of x, the outer functions is f, and evaluate at the inner function g of x. It is the derivative of the outer functions evaluate at the inner functions g of x, and then multiply to the derivative of the inner functions. Okay. So then in this case, so maybe we could consider this one. So y equal to 2x to the power 3 minus 3x to the square plus 2 raised to the power 5. Okay. So in this case, you could consider that here, okay, the functions is like a power function, something to the power 5, which is my outer functions. Okay. So therefore, the derivative of the outer functions is, okay, the derivative of the outer functions, okay, so we could consider this is something to the 5. which is x to the 5. So we bring the power down, okay? And then have something, okay, the inner function, and then this one to the 4. Okay. So again, the derivative of x to the 5 is 5x to the 4. We would like to evaluate at the inner functions, which is 2x to the power 3 minus 3x squared plus 2. Okay. And then now, don't forget that we need to take the derivative of, okay, of the inner functions. Then the result that we have will be 5 times 2x to the power 3 minus 3x squared plus 2 raised to the power 4 multiplied to the derivative of the inner function is 6x squared minus 6x. Okay, just like this. Okay, so then this idea right here is actually give us the example is we work with we combine the power rule, okay, combine with the chain rule to work it out the problem. Okay, so let's see how we work it out. Okay, so again, the power rule is tell me that if I take the derivative of x to the n, I will have n times x to the n minus 1. Okay. So then now, if n is again is any real number and u is my inner functions, okay, is differentiable, then the derivative of u to the n is n times u raised to the power of n minus 1, just like what we have here, and then we multiply to the derivative of the u, okay? Or maybe you could look at this is the derivative of g of x raised to the power of n, okay? My inner functions raised to the power of n. It will be, we bring the n down, multiply to g of x raised to the power of n minus 1, then multiply to g prime of x, okay? The derivative of the inner functions. Okay, so let's see how we actually apply this to work it out the problem. So first of all, to this a right here, I have f of x is the square root of 4 minus 3x. Then we could rewrite this into 4 minus 3x raised to the power 1/2, right? Okay. Then let's consider, if I want to take the derivative of x to the power 1/2, then it will be 1/2 x to the power of 1/2 minus 1. So the result will be 1/2 x to the negative 1/2 then. Okay. Okay. Then let's see how we apply this to again the power rule combined with the chain rule now. Okay. So in this case, my f prime of x is again consider that this is my inner functions. Okay. So then I will bring the power of 1/2 down. Evaluate at 4 minus 3x is my inner functions raised to the power of negative 1/2. Okay. It's just like we replace x with the 4 minus 3x. But don't forget that we need to multiply the derivative of the inner functions, which is 4 minus 3x. Okay. So in this case, it will be negative 3 So I will have 1/2. 4 minus 3x to the negative 1/2 times negative 3. And now 1/2 times negative 3 is negative 3/2. Okay. And then this one I could write it as 1 over 4 minus 3x to the 1/2 power. Okay. Then it could be what is the negative 3 over 2 times square root of 4 minus 3x then. Then now let us look at how we work with the b now. Okay. Now again, this problem b, you could consider that just like what we have it before. Then we assign the power, okay, to be my inner functions. So basically the form of this function y equal to e to the power of 3x squared minus 2x plus 10 is like e to the u, okay, where u is the 3x squared minus 2x plus 10. Okay. Then, but with the chain rule, it will be e to the u prime then. Okay. So then, in this case, my answer to this one, it is y prime is e to the u multiplied to u prime. And then, of course, to this one, the derivative of 3x squared minus 2x plus 10, it will be 6x minus 2 multiplied to e to the 3x squared minus 2x plus 10. Okay. Okay. Then now, let's see how do we actually find out that the derivative of a to the x. Okay. Okay. And now, before we actually work it out, this one right here, I don't know if you remember that I could write a equal to e to the natural log of a. Okay. Again, when we have a to the b equal to c, we can rewrite this into log base b of c equal to log base a, my bad, it should be log base a of c is equal to b, right? Because in this case, this is the base that we have. Okay. Or we could rewrite this because of this situation right here. Then we could rewrite this a to the power of log base a of c. Okay, because again, b equal to log base a of c is equal to c. Okay, so meaning if we have so if these two base they're the same, then the power is my answer. So if this is the case, that means if I have e to the log base e of x, okay, then my answer is x. And log basis of x is the ln of x, which is equal to x then. So meaning in this case, if I have a will be e to the natural log of a then. Okay. Okay. So let's see how we use this one to help us to work it out this problem. Then now I would like to start with the left-hand side, which is we take the derivative of a to the x. Okay. Again, I would like to show that it is equal to a to the x natural log of a. Okay. Then now I would like to rewrite a to e to the natural log a. And of course, we raise to the power of x then. And now, then we could multiply these two power together. So I take the derivative of e to the natural log of a times x, or write it this way then. Okay, x times natural log of a. And of course, in this case, we will be able to use the rule, right? It is e to the u. Derivative of e to the u is e to the u prime. Okay. So this is my u then. So then in this case, I will have e to the u multiplied to the derivative of x times natural log of a. Okay. And if you remember, okay, again, the derivative of 2x is 2, okay? So because 2 is a constant. So in this case, you will see a natural log of a is a constant. So therefore, okay. So then in this case, the derivative of x times natural log of a is just natural log of a. And now, what is this one right here? You will see that this one basically is a to the x. So I will have a to the x natural log of. Okay, so the derivative of a to the x is a to the x times natural log a. Okay, so in this case, how do we actually work it out the derivative of 2 to the x then? Then now, the derivative of 2 to the x will be 2 to the x natural log of 2, right? So this is the idea. Okay. Then do you remember that the derivative of e to the x, oh, it's actually e to the x, right? So in this case, if we want to use this rule right here to help us to take the derivative, let's see, okay? So the derivative of e to the x, it will be e to the x natural log of e. And then remember natural log of e is 1, right? Well, then we get e to the x, okay? And now let's see how to work it out. The derivative of the function. We are going to practice this. Okay. So again, we have a to the x. The derivative of a to the x is a to the x natural log of a. So then if I want to change x to u, then it will be a to the u natural log of a. But remember, we need to take the derivative of u, so we multiply to u prime. Okay. And now, this one is just like the u that we have. Okay. So then y prime will be 3 to the tangent of x. Okay. And then natural log of 3. And we need to take the derivative of tangent of x then. Okay. And again, the derivative of tangent of x is secant square x. So my answer will be 3 tangent of x, natural log of 3, and then secant square x. Okay. Then this is my y prime. Then how about this one? F of theta equal to tangent square m theta. Okay. Now, when I work it out this problem, I would like to rewrite the tangent square theta. Tangent square m theta, I would like to rewrite this into tangent of m theta and then the whole thing to the square. Okay. And now, when I try to find the derivative, then first of all, I would like to see how do I work it out the u square, right? So in this case, the u square will be, the derivative of u square will be 2u u prime. And then second, I also need to work with the tangent. So again, I will have tangent of u. In this case, tangent of u, it will be secant square u, u prime. And of course, we also need to work it out. Again, you see m theta is the inner functions. So we also need to know the derivative of m theta. And then in this case, it's actually equal to m then. Okay. Okay, so once we know this, then let's see how we work it out, the problem. First of all, I would like to take care of the u square. Okay. That means I will have 2 times u is the inner function, which is tangent of m theta. And we would like to take the derivative of tangent of m theta then. Okay. And then now we can just write this down. So I have 2 tangent of m theta. Okay. And I would like to take the derivative of this. Okay. Again, this tangent of m theta. Okay. You will see that to this one basically is we could use the tangent of u, this one to help us to do this. So then it will be secant square u. U is my inner functions, okay? And then now I also need to take the derivative of the inner functions. So I will take the derivative of m theta then. Okay, so then now my result, it will be 2 tangent of m theta secant square m theta, and the derivative of m theta is m. Let me rewrite this. It will be 2m tangent of m theta secant square m theta. Okay. So this is the idea about the chain rule, meaning to this problem, okay? So if you have the inner functions, or maybe I should say that if you have the inner functions within another inner functions, okay? Then in this case, you are going to calculate the derivative, okay? Until you take care of all the inner functions, then you are done. Then now, let us look at our next example, okay? Again, to this one, I have the sum. So if I have a summation, so I would have this is f prime of t is the derivative of psi of e to the t plus the derivative of e to the psi of t then, okay? But now, I have two functions. One function is kind of like psi of u, okay? So the derivative of psi of u, it will be cosine of u, u prime. Another one is e to the u. The derivative of e to the u is e to the u, u prime. Okay. then let's see. So to this one, the derivative of the outer functions, okay, the sine function is cosine. So I have cosine of e to the t divided at the inner functions and multiply to the derivative of e to the t. Plus, okay, so again, my outer function is the form as e to the u, okay? So I will have e to the sine of t, and I take the derivative of the power, right, the u. And now, the derivative of e to the t is just e to the t. And the derivative of sine of t is cosine of t. Okay. Yeah, that's it. Okay. Then now, let's see how we work it out the last problem, which is D now. Okay. Then first of all, you will consider that this is just like sine of u. Okay. So the derivative of sine of u is cosine of u prime. Okay. Then now, the next function is secant of tangent of z. Okay. Then again, we could actually consider that is secant of u. So the derivative of secant of u, it will be secant u tangent u prime. Okay. And of course, the last one will be tangent of z. And then the derivative of tangent of z, it will be secant squared z then. Okay. Okay, so then let's see how we actually work it out this problem now. So then now I will have f prime of z. It will be, okay, again, we work with the outer function is a sine, so I will have cosine of u, of u, and then u prime. Okay, so then now, okay, I will be able to just copy this down. So I have cosine of secant of tangent of z. And now the derivative of secant of tangent z. Okay, so is we are going to use the secant u. Okay, so then to this one, maybe let me, okay, again, we are take care of this. So I will have this one is kind of like we will have secant u tangent u and u prime. Okay. And now let's see, my answer will be cosine of secant of tangent of z multiplied to secant u tangent u and then multiply to this one here. So I will have secant square c. So this is my f prime of c. Okay. Okay, so to number 7, we need to again need a help with a ruler, okay? Because we need to find the slope of the tangent at the point. Okay. Okay. So again, go back to the definitions. Okay. So if I have f of g of x, okay, if I take the derivative of this one, it will be f prime of g of x times g prime of x. Okay. So this is what we have. Okay. Then now let's see how we actually work it out the problem here. Okay. So to this problem, you know that h of x is f prime of f of x. So if I want to find h prime of 2, okay, then what we need to do, okay, so we need to follow the kind of like the step and procedure, okay. Then first of all, to step 1, we need to find the h prime of x first. Okay. So then in this case, we have h of x is f of x. Okay. Then of course h prime of x is f prime of f of x times f prime of x. Okay, so step 2, it will be h prime of 2 is f prime of f of 2 times f prime of 2. Okay. Then now, step 3, we have to go back to the graph now. Okay, step 3. We have to again work with the functions. Okay, for the graph. Then now, what we need f of 2 and also f prime of 2. Okay. So of course, f of 2 is when x is equal to 2, then my output is 1. So f of 2 is equal to 1. And remember, what is f prime of 2 is the slope of the tangent line at x equal to 2. So this is the reason why we need to use a strict object, right? Okay. And let's see if we could find a good approximations then, okay? Okay. Then okay. So to this one, you will see that basically the slope is like -1 in this case. Okay. And now we could go back to the problem now. Okay. So then in this case, then I could work with the step 4. H prime of 2 is equal to f prime of, again, f of 2 is 1, and f prime of 2 is -1. Now, of course, right now, what we can do is we could go to step 5. We would like to find out that what f prime of 1 equal to. Mhm. And again, 1 is right here. And now let's try this. Okay. Then let's see. Okay. So we could consider that to this one, we could use this point, and then maybe let's see. Okay, maybe this point then. Okay. Okay. So to this one, we go down by 1, 2, 2.5. Okay, so we go down by 2.5, and then we run it by 1, 2, 3. Okay, 3. Okay. Then to this one here, then we could write it as maybe 25, negative 25 over 30. Okay. Multiplied by 2, negative 1. Okay. So the answer that I have, it will be 25 over 30 then. So maybe I call this step 6 then, right? Okay. And now the answer that I have will be h prime of 2 is 25 over 30. Mhm. Okay, so right now it is your turn. Go ahead and try to see if you could work it out the next problem then. Okay, so step 1, I would like to find g prime of x. Okay. And we know that g of x equal to f of x squared. Then of course to this one is g prime of x, it will be f prime of x squared times the derivative of x squared then. So which is 2x, f prime of x squared. Then step 2, we would like to find g prime of 2. Okay. So we will replace all the x with 2. Then I will have 4 times f of 4. Oh, actually f prime 4. And now go back to the graph. Then step 3, f prime of 4 is equal to okay. Okay. So it seems that we go up by 1, 2, 3, 4, and then 1 by 2. So it is about 2 then. Okay. So then now we have 4 times 2, which is 8 then, okay? Okay, so now let us work on our last example, okay? Okay, so to this problem, again, I would like to find the value of x. Okay, does the function y has a horizontal tangent line? And then again, when you see that we have horizontal tangent line, please tell me that I would like to find where f prime, y prime is equal to 0 then. Okay, so then let's see. So first, I would like to find y prime. Okay, so the derivative of psi of x is cos of x plus, okay, again, remember psi of x to the square is psi square x, right? So then the derivative of this one here, it will be 2 times psi of x and the derivative of psi of x. So it will be 2 times psi of x cos of x. And then I would like to set this equal to 0 because we would like to find where the function has have horizontal tangent line. Okay. Then now we have a common factor, so we could take out the cos of x. Then I have 1 plus 2 times psi of x equal to 0. And of course, I will have cos of x equal to 0 or 1 plus 2 times psi of x equal to 0. And now, okay, to the cos of x equal to 0, we have this. It will be pi over 2, 3 pi over 2, right? And then 5 pi over 2, and so on and so forth. So then, in this case, we could write the answer, okay, x is pi over 2 plus, again, you will see that from here to here is pi, and then from here to here is 2 pi. So I could write down as k pi, where k is an integers, right? Okay. And now, how about this one? So I will have 2 psi of x equal to -1. Then I have psi of x equal to -1/2. Okay. And again, if psi is negative based on ASTC, so meaning x is in quadrant 3 and 4. So quadrant 3 and then quadrant 4, right? And now I would like to find out this angle is what we call the reference angle. Okay? Then now, psi of x bar is the absolute value of -1/2, which is 1/2. Then I have x bar is pi over 6. So then, okay, this one x, so I have x will be pi over 6 plus pi plus 2k pi. So which is 7 pi over 6 plus 2k pi. And the one in quadrant 4, it will be x will be 2 pi minus pi over 6 plus 2k pi. I will have 11 pi over 6 plus 2k pi. Okay. Again, where k is an integers. So then now the result that we have is x it will be pi over 2 plus k pi, 7 pi over 6 plus 2k pi, and also 11 pi over 6 plus 2k pi. Okay. The k is an integers. Okay, so then that is it for this lecture. Thank you.